name is Tiffany, and I'm BSI leader for EF 151. Today we'll be talking about free body diagrams. Free body diagrams are often used in the study of physics. These diagrams are used to show the relative magnitude and directions of all forces acting upon an object in a given situation. Here is an example of a free body diagram. Here we have a car that has some weight, so we have some gravitational force. And every time we have a gravitational force, we also have a normal force. Because if the force is not balanced, the car just fly up or fly down. And here we also have someone that's pulling the car, so we're experiencing some tension force. And we have someone that's pushing the car, so we have an applied force here. At the same time, the car is also experiencing frictional force, and the frictional force is always opposite of the applied force. Here. The arrows are used to represent all the forces. For example, normal force, gravity force, tension, friction, and applied force, etc. Usually, a box is used to represent the object or the particle. It doesn't really matter what the actual object is. It can be a car, a person, or a pig. A box is used to represent any of these objects. So here, instead of the car, we can just draw a box. So here we have an example of drawing a free body diagram. A cup is moved horizontally across the table by a leftward force at a constant velocity. Consider frictional forces and neglect the air resistance. So as I mentioned before, the object we can just use a box to represent. It doesn't have to be an actual cup. And for all objects, we always have a gravitational force, which is the weight, and we always have the normal force, as mentioned before. In the question we said that there is the applied force that moves leftwards. So here's the applied force going left, and we also have frictional force that's in opposite direction from the applied force. So it's the other way. And this is an example of drawing a free body diagram. Here we have another example to find the values of forces using free body diagram. We have a tractor that's pulling two carts here. The tractor pulls a tractive force of 68 pounds, and we have to find the force of the coupling that's pulling cart 2. First, we have to consider the entire system. So we consider the whole system using a box to represent all three carts. It's experiencing gravitational force as always and normal force. At the same time, we also know that there's a 68 pounds tractive force that's pulling towards the right. So 68 pounds here. Here we have to find the acceleration that's pulling this whole system. To find the acceleration, we can use the relationship of force is equals to mass times acceleration. To rearrange it, we have acceleration equals to force over mass. Using this equation here, we can find our acceleration for this system. So our acceleration for this system is equals to 68 pounds over the mass of all of the entire system. So it's all three of these objects. So we have 160 pounds plus 120 pounds plus 420 pounds. This is the force. To convert it to a mass, we have to divide it by the gravitational pull, which is 32.2 in the English system, feet per second square. To calculate that, after we calculate that, we have an acceleration of 3.128 feet per second square. Right here. After we use the whole system to find the total acceleration, we can use this acceleration to find the coupling force in just cart 2. So now we're just focusing on cart 2. So again, we're using a box to represent cart 2. It's experiencing some gravitational force and some normal force. we know that there's a coupling force that's pulling this way, and this is the force that we need to find. Using this relationship, force equals to mass times acceleration, we can apply it here. So our force is the coupling force equals to the mass, which is 160 pounds, divided by gravitational pull, which is like just now, times our overall acceleration. So it's the acceleration that we found previously. After we calculate that, we found out that our coupling force is 15.5 pounds. And here is how we find values of forces using free body diagrams. And now we have a challenge for you. A printer which weighs 3 Newton is rest on a desk. You have to draw the diagram with all forces acting on the book and find out the normal force acting on the book. The answer will be posted on our Facebook page in a week. Good luck!